Muted, that's why you can't hear our clap.
Yep.
Thank you for muting and laughing. Okay, we'll give it one more minute. It's only fair that we start on time, not before. Anybody, any expectations from the call today? Oh, okay. And
Yeah, no expectation. These days, that's why I'm going to watch movies.
What was that, Arvind? I missed out the last part.
So without any expectation, I'm going to watch movies these days. That's why I'm watching this.
I hope this will not be an utter flop, even if it wouldn't be a box office hit. Said that I can assure you.
So
Don't worry,
I'm not
guys. Yeah.
what are the topics we are going to cover. But if you cover the basic things like how some of developers, how we can take our code to AWS and get a live URL, then that's great.
No, don't set too much expectations. This is a multi-part session, Arvind. So
Oh, sure.
we'll surely go there. What you said is surely not away from what we want to do. But in today's session, I will start with the basics so that if I believe there is like some people who can, benefit from this. So if you are somebody who has already, been like, let us say, used AWS console, then you can actually drop off. Don't waste your time on this. But if you're not, if you think that, there is, some basics that you would like to get right, then you can continue on this call. Or else, please drop off. No offense. Totally fine if you have used the AWS console. That's, a prerequisite for the next session. Okay. It's okay if you want to continue. No issues. Arvind, sometimes you do watch some movies again, right?
No, I'm not good at this consulting.
Sure, we'll start off then. Okay, so thanks everybody. Thanks for joining. Let me share my screen, bring up a 47 slide deck that we are going through in the next half an hour. Somebody fainted. Okay, let me know when you can see my screen so that I can start.
I can.
Okay.
I can.
Okay, so
Yeah,
like the perfect. Thank you. Do let me know if you want to unmute and ask questions if you want explicitly in between, or else you can wait to the end of the session. I'll try and run through this quick session. Thank you for your time today. The idea is that, irrespective of your track, you are in cloud, you are in data, you are in, product engineering, or you're totally, on delivery, QA, all of that, you need to know the cloud because most of the services are run on the cloud. So the idea today is to, traverse through, understand the cloud, AWS Cloud or Azure or Google, not much of a change overall in the system per se, but there would be minor differences. But if you know one, you'll be able to traverse other. That is the idea. Okay, so uh, again, this session will be the first of many. If somebody is really interested and come back to me asking for some specific sessions in addition to this, I will be very happy to take them through and get you up to speed on the cloud. Okay, so going into it, first and foremost, we'll understand why cloud is a hit. So I'll take a little bit of a time and explain that so that people are all aware. So generally, what happens, people, is that when there are systems that you build. And there is a deployment coming up or even to build, you need to provision some environment or you need to have some infrastructure to get things up and running. You go to Jacob or you go to somebody in the team, ask them to set up your application, web application, if say, or database, and then get it ready. So that's the general on-premise method that used to be there earlier, that you have to go buy this infrastructure. It used to take a lot of time, approvals, etc. And then there happened cloud. So when cloud happened, everybody started to just be able to go do a few clicks and get the application up and running. So that is why it was become possible that we are able to launch and speed up the infrastructure setup. But at the same time, you only pay for what you need. If I am going to do that, I would be if I am going to buy something on premise, I would have had to purchase more than the bare minimum, because tomorrow if I want to increase the amount of storage or something, then I would need that infrastructure setup, right? So that is where we purchase more than what we need, and we pay for it, we keep it running. But with the cloud, because you are doing a cloud infrastructure that is totally virtual, you can just pay for what you need, use what you need, and pay for it. Okay, so that is a one reason. That's one amazing thing that cloud brings to you. Of course, because of this factor, it automatically lowers the total cost of IT. There would be a lot of discussions on this many years back, so I'm not going in detail today because everybody of us is sold out that cloud is the right thing for infrastructure. So we will go with that, but I'll just call out this, it reduces the total cost of IT. If you have doubts, you can always, explicitly come to me. I can show to you how an AWS calculator works on finding out what cost it actually takes to create an IT infrastructure. Yeah, the other thing is that about capacity. Like for instance, Arvind, Brahma, and I, we were on a call yesterday for the Cloud5 customer. They had a database that is running on, let us say, about $300 per month cost. I'll go to the capacity part eventually, but that is a 4 CPU with 32 GB RAM, and that performance was not great. So we are stepping it up because they reduced it earlier when they found that the pandemic was reducing the hotel bookings for their customers. But now that it is up, the performance needs to be made up. It's just a configuration change. You don't have to worry. You can just go and increase it. So automatically that elasticity comes in, and it allows you to increase to the demand that is there today. So that's the capability of cloud, right? Innovations, of course, because yeah, experimentation is always something that you don't invest too much on. You need to be having that elasticity to quickly do some experiment, get back and say, okay, I'm done, stop the instance. So that's that innovation increase that automatically happens along with the cloud. Okay. Again, all the heavy lifting, all the unnecessary work. Imagine we had a data center within office to run all these instances. We should have somebody taking care of the racks, the servers, the cooling, the power, the networks, all that stuff. Now all that is taken care because we are outsourcing this onto the cloud. They are doing it on their side, but we are not doing it on our side. That is understanding. Okay, let me pause. Let me understand if somebody is still around. Am I going at the right pace? I hope so. If you have all not fallen asleep, I'm happy. Thank you, the rest of the people. I'll keep continuing. Okay. And the other part of this, right, the other major, advantage that you can see is that you do not have to worry about edge computing. If you have to provision something in the US, etc., earlier, you should go to a, provider. There's a large process. You have to get them validated. You have to then position your server there. You have to get a connection from here to there. Many of you should be happy that you're not living in that era where you need to set all that up to get to that level. But now it is drastically improved because within a few clicks, you can provision your system or your servers anywhere in the world, almost anywhere in the world. Okay. So that's one more advantage. Now, done with that
Ashin, sorry.
advantages. Yeah.
Yeah, Ashin, what's this edge computing? Can you?
Sure. See, edge computing in a real meaning is that assume that let us say, Aravind, you are working on the Cloud5 environment, right? Just for the sake of conversation, and what you do there is you set up something for let us say the what was that? What was the name of the app that you are building right now? The
Helios.
Helios, right? Okay, Helios is a good app, right? So Helios is set up in 2-3 data centers within the United States. So now imagine this migrates to some other country, right? And I'm talking from this context. I'll come to edge in a minute. So I'm migrating the Cloudflare environment from there to, let us say, Japan or maybe Australia, right? So when somebody wants to work on Helios, they browse something. The data has to be transferred from the user experience itself, the UI, the contents, all of it has to travel from all the way from there to the Australian subcontinent and then back for every request. That going to be having a latency, even if at all how much our fast the networks are, that will surely be a latency in terms of how it works, right? So that is where it is always a dream for somebody to take compute and storage to as close a location to the user as needed. In this case, as it is a web application, you may still just distribute it. We wouldn't call it edge computing, but in real sense, edge computing is something that where the compute power is not just centralized in a location, but distributed to edges or nodes. When we say edges, there could be multiple different factors. Primarily from the IoT perspective is where edge comes in place, where edge computing is like I again mentioned, instead of the server, the IoT device that might be an edge. Like for instance, let us say a CCTV camera, right? In a CCTV camera, if you are going to capture all the images, send it to the central server. Imagine in a big warehouse where are hundred of CCTV cameras, and a face detection has to happen. All these images has to be processed centrally. But instead, if I put a bit of a smart cam on the edge, I allow that computation to happen there. And if I say, let us say, I see a fire happening, that edge compute can automatically detect it and then raise the alarm, right? So that is an example of an edge computing where the distributed mechanism helps get the work done sooner and faster in the edges. Makes sense, Arvind?
Yes. Thanks,
Yeah.
Ashin.
Yeah, so that applies to this as well. It allows you to distribute the work globally, like edge computing, and there is actual edge computing capabilities in the services as well from AWS and Azure. So we'll go to that in one of our future sessions. Okay. So that brings us to the core components or core types of components that AWS provides, right? Today, when you see, you would be aware of there is some compute. Like for example, on your computer, there is a compute, there's a storage, and then maybe some database on top of it, etc. There is surely networking, and then you run applications on it, and then you do stuff with application like deploying and administration, all that. Same thing applies to the cloud, right? All this has to be done there too. Ultimately, what you do on a computer is what you will do on multiple computers and a network of computers too. So that is the same concept here. So oversimplifying it, there is going to be a global AWS infrastructure that is hosting all this virtual networks and computes on top of it, in a very effective, efficient manner. If you listen to some of the podcasts that the AWS infrastructure guys talk about, you'll be amazed by the kind of performance that some of their devices are built towards. It used to be earlier commodity, infrastructure that was bought together to build all this, but now they are going to specific capabilities. Like for instance, I think the recent blog I was, or recent podcast that I was listening, one of that AWS architects was talking about having a chip that is doing the virtual network routing capability, and it is capable of handling billions of bytes every second. And it's like tremendous because those networks to a very great extent contribute to the performance of an application. Because if imagine you have a network which is slow, you have a cable that takes the data and it limits the performance. Rather than that, if you add it all together, put it all together in one spot, it is going to drastically improve the performance of your application overall end to end. So they are the organizations, the big cloud players are focusing on building specific infrastructure components that can drastically provide value for all the money that you put in there. Okay, so that brings us to that more details of where this AWS cloud is. Of course, it is in the sky, right? Hopefully, not everybody agrees. It is not in the sky. It is in locations, and many of them are actually even underground for safety reasons. These are distributed across various locations as you see here. So this actually means that like as you see here, India, in UAE, in the UK, in USA, in Africa, in China, in Japan, Australia, all these areas there are regions. And when we call region is basically a combination of availability zones. That is what they call. An availability zone is a data center. So imagine that in a data center, and a data center is in a massive scale. Again, it's not just one rack or so. There are thousands and thousands of racks in each of many of these centers or availability zones, and a region will compose of more than 3 availability zone. That is the combination. So let us say in Virginia, where Scott stays, so there is a North Virginia region for AWS. So when you say that there is a region that actually composes of about 3 or 4, I think even more, I think 5 availability zones within that area. That means about 50 or 100 kilometers, or about 50-60 miles apart. Each of those availability zones are connected through high speed networks, etc., so that this make it impossible for a simple or a medium size catastrophe to affect any of this. These are individually powered, have great backups, have great networks connected by different providers, etc. All possible capabilities are being brought in into these regions to make sure this availability is increased. Okay, so that way you can distribute your work across each of these continents or regions, so that if something goes down totally, even if a continent worst case goes down totally, your data is still resident somewhere, and even your application can get up and running faster. Okay, so that's the capability that cloud provides. Imagine doing this for your one application to be able to available across a few countries, is a nightmare if not for this cloud providers. So these are the cases, some of the taken for granted capabilities that cloud gives today. Okay, so coming to a little bit of on the purchase. Okay, it is true all that is said, but how much does it cost? There are some free tier data, the free tier compute and data that provisions that are provided to you. You can register and start using it, try it out for POCs, etc. I think about $100 worth of capabilities provided if you register online and try out a few things. If you have not yet done, try it out. It's as simple as what I'm going to show in the next few slides, but it will help you get your hands dirty and start using the cloud. Okay, don't get left out. Don't be a grandma who doesn't know how to use a smartphone equivalent in today's cloud computing world. Okay, so now after free tier comes the on-demand, which is the common instance that normally organizations start off with. But then when they see that on-demand has been being in use for a few months, they reserve those instances so that that instance is available for a few. Just a second. Pardon me, I was sneezing and I didn't want to frighten you. Okay, so the reserved instance mechanism is to reserve the on-demand instances that you took, so that it will be available for a while and is dedicatedly provided to you. In the case of on-demand instance, if some instance is very much in demand, you may have a chance you may not get to use it at times of spikes. Okay, then comes a spot and a dedicated instance. Dedicated instances are, of course, instances that are beyond reserved. They are, launched and set up very specifically for some specific needs where there might be, worries of security, etc. That's a, delicacy, if you may. But then spot instances are something that you can bid for and use, as required, and then throw it off, or it will be revoked when that spot is taken over by somebody or at a higher price. This is more like a sort of a gamble, but it's a very good gamble if you do not want a dedicated instance. If you want to do some R&D and you want to use drastic amount of compute, you can think about the spot instances. Very interesting stuff. Make notes and look it up. You will be able to understand a little bit more of all this. Okay, moving on to there comes the one of its kind, the compute services. So like if you remember this deck from here, compute, storage, databases are some of the very core services. So one of and the set of such services that are available, EC2 is a very common compute service. EC2 stands for Elastic Cloud Compute, which is equivalent of your virtual machine, a virtual server, right? A difference between a physical server and a virtual server is that a physical server is of course your laptop, desktop, servers in the rack. The virtual server is what makes it possible to have multiple servers on top of a server. So that way the elasticity is brought in into the software that runs the original virtualization server. Okay. Okay. So now, think about it as, computing services are the RAMs and, processors that are, provided for getting work done. Okay. Let us quickly go and see what it really takes to actually create one instance. Okay. So literally, these are some of the steps. Yeah, it looks like quite a few. Don't have to read it through. I will quickly go in and show you. If you go into the console, you will see a menu of all the types of services like what we saw there. Compute, storage, database, networking, etc. If you select compute, it will show you all the EC2, and then you choose EC2. Then you will show you all the different types of EC2s that are running. There are dedicated hosts and the elastic IPs and the volumes that are attached to it. We'll go into a little bit of that, but before that, let us go and click on the, let us make sure that we are choosing the right region where we want to launch this EC2. So you can choose out of the many regions that you saw in the image. Then when you go and click on launch instance, that is where it lets you choose an Amazon machine image. For people who have installed their own operating systems, this is more like a USB or a CD, DVD that you need to put in to load that image from. So in this case, they are choosing the Linux, Amazon Linux AMI, the Amazon machine image that will have the pre-installed version of that Linux for that version with an SSD volume type. Okay. So then you select that AMI, then you choose the size of the instance. This is very critical. This instance type choose that determines how much cost you'll have to pay. Some of them are free for a particular time, but then as and when you step it up, the cost increases. If you look at the T2 Micro is actually a 1 GB sized compute instance with just an elastic beanstalk, elastic block storage only attachment to that. Okay, and then you select next. You then queue the number of instances you want to launch. It's not just that you have to create one by one. If you want to create hundreds of instances in one shot, that is possible too. When you will do it, let us assume you are doing a load testing, like what you learned from Melvin's session last time on the JMeter. You set up a JMeter instance, you create an AMI, you launch hundreds of such instances, you can multiply the load so much to increase along with it. Okay. And then you choose whether it is a spot instance or not, skip it for now. You have to choose which network this is going to be. So assume that if you are in a computer, you would have chosen which IP address and which set of subnet it would belong to. Equivalent to that, you choose a VPC, virtual private cloud. In one of our future sessions, we'll go in deeper into VPCs if you are interested. And then you choose the subnet within the VPC where it should belong. Some of them will be private, some of them will be public subnets. You can choose some of them, one of them, and then you can enable to assign an automatic IP or DHCP equivalent of it, and then you choose an IAM role. IAM role is more of an identity and access management role on how it would be managed. This would be helpful if you are installing it in a bulk or where you can use keyless access into these instances. Then when you shut down this instance, do you want to stop it or would you want it to terminate? Is an option. It gives you there are quite a few such you can prevent it from getting terminated by mistake by enabling this. You can enable CloudWatch to monitor it. You can run it as a shared instance. Don't worry, some of it might be Greek and Latin, but overall these are some of the steps that you just need to fill in as easy as what you saw here. Click, review and launch. Set up the storage, how much space you want to increase that storage to, what type of storage you want to provision it with SSD or a magnetic disk kind of a storage, etc. And then you provide some tags so that you can search and look it up later. Then the next step is to configure the security group. This is more like a firewall. So you can say that this security group, all the instances within that security group are able to communicate within each other. They can talk outside with this IP range, etc. All that can be done, right? And then you review and launch the instance. And this is the final step. You say, okay, this is all what I gave. Fine, all that is fine. Then at last it asks you to choose a key pair where you go select this is the key value pair with which I can access this. This is the security token equivalent of this, right? You can download the key pair and if you create a new one and keep it for later use. Then you launch it. It will launch. It will take a minute, sometimes even sooner it will launch. And then it will show you this list under the launched instances. And then once it is launched, you can see that it is running. And then what you see is the private IP that has been assigned to it. From then on, you can use a private IP to access it if you're from within the network, or you can assign a public IP and access it from outside. All that stuff is so cool. It's as simple as what you saw here, right? Try it out. Take the free instance, try it out. You'll get an idea. Once you get an idea, then you are already a person who's already using it. So there is no more turning back. Okay, and this is just about EC2s. There are hundreds of services that AWS provides. Some of them are in the category of network services. Like for example, in this case, Route 53 that you see here is a DNS service. Today you would have GoDaddy. Instead of GoDaddy, you can go to Route 53 Daddy, right? You can go get your own URL. You can assign it to one of your instances, EC2, and you are done. Your work is done. You are an entrepreneur having your own instance, your own domain name. All that is as simple as that. For enterprises where you need dedicated lines between your office and to the cloud, there is a connection called Direct Connect. That's something that's a little bit more advanced. You can go in eventually there. Storage, when you have all this stuff and if you do not have anything fancy for storage, it is a shame, right? So that is where S3, the most commonly used AWS storage, is available. Amazon S3 is for storing all different types of files, etc., in a more like a folder file structure that you can use it for. It's a key value pair store. Again, internally it's one of the big data storage. You can access it via API through UI. It's very cheap, to the extent that if you are really worried about all your cost in that's in terms of your Google Cloud costs that are coming up, you can always set up something on S3 and you can start using it to back up your files and stores into there. Okay, there is a block storage which is more useful for a EC2 attached usage, more like an hard disk that is available. And then there's a Glacier storage which is slower than S3 but way too cheaper. So if you have terabytes and gigabytes, petabytes of data, then you go to Glacier to store it. But it takes about a day to retrieve from there and review it. So very old data that is really not required goes into Glacier. And then there is a storage gateway for integrating with on-premise sort of a mode. Okay. There are quite a few other application services that enable, like for example, the CloudFront is a CDN, content delivery network. Again, sort of an edge, capability, not edge compute, edge capability that enables you to cache data across the globe so that your end users get much faster a feel when they use it. This is equivalent of the similar services that we have. Cloudflare is what we use outside CloudFront, outside AWS for our organization. Right, and then cloud search, managed services are there, video transcoding devices are there, all that are available on the option. And this is like a bare minimum few that I just took off the shelf right from some deck. Quite a few services you should be going through, browsing through some of the services that AWS offers. Database services, your RDBMS equivalent is available as an RDS. Within that, you can choose SQL Server to be launched, or Oracle, or MySQL, or DB, all those different type of capabilities, MariaDB, all that is available on the RDS service itself. Then comes your DynamoDB, which is your NoSQL from Amazon itself, right? So literally, what it is also about a key value pair sort of a store, cloud, mainly columnar, compute. So get to know a little bit about it. Don't stop there. Launch instance, try out it. You'll understand how very easy to use it. Your MongoDB equivalent of Dynamo, Amazon's service is the DynamoDB. Then comes the Elastic Cache. Again, for using caching services. Then you have your big data services and many such. If you have Jenkins or anything of the sort in your team, you know that deployment and administration is very important for any application. So there are some services, Aravind, like you asked in the beginning, from your point of view, that can enable deploying an application from code onto the actual serverless compute Elastic Beanstalk. So that is possible using some of these services, right? Then this is a sample deployment diagram which shows how users reach out to Route 53 for the DNS. They go to the CloudFront for the CDN and they access the data stored in a S3 bucket for like static content. For dynamic contents, they go through a load balancer into different EC2 instances, or if you require serverless compute, you can go into even better, a beanstalk or a lambda to get your code executed and then you take data from the storage and show it. So all these are different means of doing this. So these are the other options deployment wise. That's not like you have to do everything on the cloud. You can have some on-premise, some cloud. You can go from there to to the next level. I'm rushing through so that I'll complete it and give a little bit of a time for asking questions. These are again, common services that are existing on-premise when compared to how we can do it on the cloud. Nothing specific. Slow to, yeah. So how we can enable, the addition of an cloud service to speed up or improve the quality of your customer or an internal organization's experience is what this calls out. That's all. I'm going to stop the sharing and I'm going to check if anybody has any specific questions. If you do want to know anything in specific about any of this, please reach out to me. I'll be happy to conduct a session. I anyway plan to do something on big data shortly, but that may not be explicitly on the AWS. It could be a little bit more generic or specific to a particular NoSQL solution. Too much for a 30-minute session?
Thanks. Thanks. That's a good insight.
How was the movie, Arvind?
Nice one.
Not bad, no? Too fast. Like,
No, I think there are a lot of content inside.
okay. Yeah.
So we can try out, and I mean, guys can try it out and just check.
Yes. See, the key to the success of this session is you going back and trying it out, each of you. Don't use organization compute. It'll kill, because if tens of people go and launch, it'll take a lot. If you don't stop it, mainly, if you stop it, the impact will be less. So even when you do it for yourself, take the free tier, try it out, stop the instances when you're not using it, and have fun learning how to do AWS Cloud. Be a great addition to your knowledge. Anybody else? Anything specific? Priyesh, you are going to say something.
Yes, actually, I just wanted to say that one session is not enough for this AWS, since it has more than 200 services and counting, actually. So yeah, thanks, Sachin, for this, and we'll continue advancing in this zone as well.
Sure. See, I will not want to take every, a session about every service, because many a service are specific to that core area. But there are some common aspects that if you're really interested, like for example, networking is a ocean. Somebody like Aravind will be, more keen because he's attempting the AWS solution architect, where networking, if you don't clear, you will not pass it, because it's a very critical factor to the success of using any services across as an architect, right? So maybe that is a candidate for use. Maybe there could be something on DevOps that we can ponder into. So there are some specific areas in the cloud that we need to be educated on or learned on, but other things you'll have to dirty your hands, find out by launching instances and trying them out. That should be the right way to approach it.
Absolutely. Thanks, Sachin. Thank you.
Sure. Anybody else? Any questions? Anything specific? If not, no worries. Please drop off. Thank you for your time. And again, thanks for getting into the cloud first step.
Yeah,